Yes, we have greater than operator, less than operator, greater than equal, less than equal, and not equal. Right now, in order to compare the two values, we could use this relational operators or comparison operators. Right. Now, remember now previously we have used the arithmetic operators. Whenever you use an arithmetic operator in with number, in return, we get another number. The result is a number. But now here, when you use relational operators, we will get a Boolean value, either true or false. Now it will return you a true or false value. Right now that will return a true or false value. Right, now let's see how can we use the relational operators. Right now, okay, if you write Java class, let's say we have a integer x equals 10 and y equals 15, and if you print if you just print x is greater than y, if you just print x is greater than y, right now we have a spelling mistake int. Right now we'll get the output like false. Right now when you say x is greater than y, now x is 10, 10 greater than 15, false. If you use the other way, x is less than x less than y. Now x less than y, it will return as a true. Now if you want to check, now if you just use 1 equal sign, now 1 equal sign is an assignment operator. Now here this is an assignment operator. Now if you print like this, what will happen? Now what happens? X equals y. The value of y get assigned to the variable x. Now this, remember this very carefully. Now equal sign is what you call as the assignment operator. Assignment operator. And it will assign the value of right hand side to the variable of left hand side. The value of the right hand side, that is y, value of variable y to the variable x. That's what it does. Then that is assigning the value. Therefore, it prints the value of variable x. Now x is 15. Now if you check whether x equals y, two equal signs, equal to. Now you can see x equals y, 10 is equals to 15. It says false. And then if you want to check not equal, x not equals y, then that will give you true. X is not equals y, which is true. Likewise, it will give you the Boolean expression as a result. Therefore, please try out less than, equals, greater than equals, equals, and not equal. Okay, quickly figure out and tell me how this works, and thereafter we're going to talk about the logical operator. Now you can see here, if you use like this now here, this will give you an error saying bad operand type. But if you do it like this, what will happen? Now we'll talk about what is this operator later on. For the time being, please practice with greater than, less than, greater than equal, less than equal, equal, not equal. Right. Okay, then if you want to compare the two numbers, if you check the relationship or if you want to compare two values, then you could use this relational operators. Right. Now then, if you want to check multiple conditions together, if you want to check multiple conditions at once. Now, for an example, the number is even number and below 10, or number is above 15 and less than 50. Likewise, if you want to check two or more conditions, then there should be a way to combine. There should be a way to combine. For that, we have something called logical operators. Right now, we have logical operators. Right. Now, sometimes you may have to have the both conditions have to be met. The number should be an even number about 20. Should be even about 20. That is must. Both condition has to be fulfilled. Then in that case, we have to have true for the both answers. If the both conditions are true, then only the final answer should be true. Now, for an example, if you want to check, right, then which operator we could use and how can we use it? Right now, basically, we have AND operator and the O operator. That means AND operator, O operator, and the NOT operator. And O, NOT, and O and XOR, exclusive O operator. Right now, these are the we have the AND operator, this is the O operator, and this is the exclusive O or XOR operator, and this is the NOT operator. Right now, then you know about now these are the logical operators and these are the relational operators. Right. Right now, for an example, let's say now I want to check the condition. Number should be even about 20. Now I can check whether how can you check whether the number is an even number? How can you check whether the number is an even number? How can you check whether a given number is an even number? How can you do that? Even number, tell me. If you guys don't know how to check a number, whether it is an even or odd, that's very difficult, a serious problem there.
If it's divisible by 2.
Divisible by 2. Okay, the number okay, now, right. Okay, before we going into this anything, I will show you how to take an input from the user, right? For the time being, how to take an input from the user, and thereafter, I want you to write a program. Okay, now talking about the input, we'll do it in a little while. Write a program. Let's say have any number here. Have any number for the x, you can assign for the x any number, and then check whether it is an even number or not, right? And how can you check whether it is an even number? Right, like this. Okay, now for an example, let's say I want to check whether, let's say, if the x value is a positive number, if x value is positive number, I want to display true. I want to display true. Then I'm going to declare a variable called Boolean variable called flag. I don't know what's wrong with this tab here in the app store. I have a variable called flag equals, I'm going to check whether x is greater than 3. Now, if x is greater than 0, that means it is a positive number. I'm going to display x value. X is a positive. X is positive number. And I'm going to display whether it is true or false by attaching the flag. Now, x equals 0. And now you can see 10 is a positive number, true. Likewise, then here the flag variable shows the true or false. Like for an example, if x equals minus 10, now it says minus 10 is a positive number, false. Likewise, it will display. Now, like this, I want you to display how can you check whether x is an even number. X is an even number. Check. Now you should remember in order to do this. Right. Now, what are the operators we have so far discussed? Arithmetic operators. What are the arithmetic operators we discussed? Plus, minus, multiplication, division, modulus. We discussed about it under the arithmetic operator. Right. Now send me the code quickly within 1 minute. Now this is what we discussed. Plus, minus, multiplication, division, modulus, and increment, decrement as we discussed. Right. Now quickly send me the answer via chat, please. How can you check whether given number is a even number? Okay, quickly send me. The time is enough now. Right, I think the time is more than enough now. Okay, only two of you have sent me the answer. How do you check it? Dehan Parent. Right, yes, modulus. Okay, right now I just want to check whether the even number only. I want to check whether the given number is an even number. Let's say I have given 10. How can I check whether the given number is an even number? Now we know already the arithmetic operators we have discussed already and the relational operators we have discussed. Then using the modulus operator, and now if you say 10 modulus 3, what do you mean by 10 modulus 3? Quickly tell me, what is 10 modulus 3?
Remainder when
The
10 is
remaining
even.
value. When you divide 10 by 3, what would be the remaining value? What would be the remaining value?
1.
10 modulus 3?
1.
Is it 0? Is it 1? 10 divided by 3 and the remaining value. What is
1.
it?
1, sir.
1. When you divide 10 by 3, 3 times 3 is 9, therefore 1 is remaining. Therefore the remainder is 1. Then if you check 10 modulus 2, right, okay, now tell me when you 10 modulus by 3, what would be the remaining values for any number? How many cases you can have? What are the possible remaining values? What are the possible remaining values? One would be 0. Tell me when you divide 10 by 3, what are the possible remaining values? Ten divided by 3 and the remaining values. Tell me quickly. Oh my goodness. When you divided 10 by 3, what are the remaining values, please? When you
1.
divided 10 by 3, what are the remaining values?
1, sir.
Right. Any number, not only 10. Any number. When you divide any number by 3, what are the remaining values? When you
0,
divide any
0,
number
1
by,
and 0, 1 and 2.
yes, obviously you can have only 0, 1 and 2. When you modulus by 3, the remain if they are if what if you getting remained as 3? For any chance will you get remained as 3 when you divide by 3? Now when you divide any number by 3, will you get the remaining value as 3 for any chance?
No, sir.
Divided by 3, you get some answer. Now for an example like this, if you divide x by 3, let's say y times you have, and then you have 3, whatever the answer, and remaining value as 3. Will you ever get the remaining value as 3? No, because 3 divided by 3 is 1. Therefore, you will never get 3. Therefore, only you have 0, 1, or 2. You can only have 0, 1, or 2 when you divide it by 3. Therefore, when you divide by 3, the remainder would be only 0, 1, or 2. It cannot be any other than 0, 1, or 2. Right. When you modulus by 2, how many cases you can have? When you divide it by 2, or when you divide it by 2, any number divided by 2, what would be the remaining values? What are the possible remaining values? When you divide a number by 2,
0
what
and
are the
1.
possible remaining values? Yes, Tehan?
0 and 1. So
0 and 1. Netindu, can you hear me, Netindu? Netindu, can you hear me?
Yes, sir.
You can hear me, right? Hello?
Hello.
I cannot hear you, Puthu. Netindu, are you there?
Yes, I'm in.
You are in. Puthe, when you divide by a number by 2, what are the possible remaining values? Any number. You're going to divide it by 2. When you
0,
divide
1.
by 2, 0 and 1. You knew that, right? Therefore, please talk, okay? Right. Everyone start talking. Otherwise, I have to pinpoint each and everyone. Right. Okay, then. Now what we have to check? Now we have to check a given number is an even number or not. Then we know that by modulus operator. If you divide by 2, if you divide the number by 2, the possible values are 0 and 1. And if it is an even number, it should be divisible by 2. We know that. If it is an even number, it should divisible by 2 and the remaining value should be 0. There should be no remaining value when you divide by 2. If it is an even number, then we can check the given number. When you modulus by 2, that means when you divide by 2, the remaining values. When you divide by 2, the remaining value should be equals to 0. If it is equals to 0, if it is equals to 0, then that value, that means the remaining value, when you divide by 2, the remainder is equals to 0. That means for sure it is an even number. Let's check whether. Right, 10 is an even number. 10 is an even number. True. Like for an example, if it is 11. Yes, for sure, we know 11 is not an even number. 11 is an even number, false. Now, this is how we check whether the number is an even number or not. The same way, if you really want to find out whether the given number is an odd number, how can you do that? Nirang, how can you check whether the given number is an even number, sorry, odd number?
By checking the remainder is 1.
Yes, by making sure the remainder value is equals to 1. Then, if the remainder is 1, for sure, it is an odd number. Then, 11 is an odd number, true. Yes, we are checking whether. So when you divide by 2, what is the remaining value? Then we can make sure, yes, the remainder is 1. That means when you divide by 2, the remainder is 1. For sure, that is an odd number then. Right. Right. Then, okay. Right. Now, this is how we check whether a given number is odd or even. Right. Now, if I want to check the multiple conditions together, right? For an example, let's say the given number is, let's say, the number should be in between 10 and should be in between 10 and 20. That means the number should be greater than 10 and less than 20. Right now, I need to check two conditions to be true. Then here it should be less than 10 true. That means we need to check whether the less than 10. Now we can check whether the number is x is less than 10. And the same way, x is greater than 10. No, about 10. X is greater than 10 and x is less than 20. Now, if the both conditions has been met, if the both conditions are true, then only If the both conditions are true, then only I need to display true. Right, now both conditions has to be met. Or sometimes we may have the number should be either, right, let's say above 20, or now you can say number should be positive or even number. Should be positive or even number. Number should be positive or even number. That means either number should be, x should be greater than 0. X should be greater than 0. That is true. Or x modulus 2 should be equals to 0. Right, now number should be a positive value or even number. Now either condition. Now if the one of the condition is true, that is okay. Right, therefore if it is an negative, that means even if it is a negative even number, fine. If it is a negative odd number, no. If it is a positive number, any number, even odd or even, doesn't matter. If it is a positive number, yes, it has to display valid. If it is a negative number, it has to be even. Then it will be valid. Then it has a condition saying either condition. Number should be positive or it should be an even number. Number should be positive or even number. Now here it's a number must be in between. Must be in between 10 and 20. It has to be both conditions. Right, then how can we combine these relations right now in these criteria? Right, first we'll check whether how these logical operators are working. Right, the logical operators we have basically AND operator, O operator. Right, now for this AND operator, now for arithmetic operator, we had numbers as the operands, like 2 plus 3. Like now for an example, we had 2 plus 3. Then this is 2 and 3 are operands and plus is the operator. Then we have used numbers as the operands. Now when it comes to relational operators, 2 less than, then we have used the numbers as the operands and this is the operator. But when it comes to logical operators, now we cannot say 2 and 3. Likewise, we cannot use. Then it has to be a Boolean value. It has to be a Boolean value. Then if it is true and true, what will be the result? If it is true and false, what would be the result? If it is false and true, likewise, we need to figure out what is going to be the result. Therefore, let's declare a variable called a Boolean variable called x and y. The Boolean variable x is true and y equals false. Right. Now let's print with the AND operator what it will result. Right, now I'm gonna use, okay, let's say here we'll have another variable called flag as well. And the flag is equals to, let's say, x and x. X and x. Right, then I'm going to say true and true and true. True and true, what would be the answer? True and true equals to. Then we'll have to have the equal sign. True and true equals flag. Right. Likewise, let's print. Only 4 cases, right? True and true, true and false. True and false. And then false and true, false and true, and then false and false. Right now, my bad, semicolons are missing. Because I'm very sorry, because now when you are working with both Python and Java at the same time, right now in Python you don't have semicolons. Here we do have semicolons. So we miss it. It's my bad. Right. Then you can see, well, okay, now likewise you can print. Now do the same for the O operator and XOR operator. Now this is for the AND operator. Like now print for the O operator and then for the XOR operator. And then tell me which operator I should use for this condition and which operator I should use for this. Okay, first tell me the answers, how you print this truth table. This we call as the truth table, right, for the AND operator. Then do the same for the O operator and do the same for the XOR operator. And then send me the answers via chat. And thereafter, find the suitable operator for this one. I think it's now you should be able to finish it. Now send me the answer via chat, please. Now, rather using another variable called flag here, you could have done it using like this as well. So next section, y. Then use operator. Then we can use XOR operator as well. And then we could use the not operator as well. Just type string working in the string. Line number 4, but yeah, my bad. It has to be inside brackets. Because when you remember that when you use it with the string value, then it does the concatenation, the plus operator, then it will put 0. Right. Now, tell me which operator I should use for the previous question here. Which operator I should use, and here which operator I should use. Tell me. What should be the operator I should use in order to check this one? Anyone? Shamodi, what do you think? What is the operator I should use?
And then O.
And then, oh, first one and operator, is it?
Yes, sir. And operator.
Yes, why? The both condition has to be true. Now you can, if you go and check in the AND operator. Now if you go and check the AND operator, now this is where we have the AND operator. Right now, when will it return true? If the both conditions are true, then only it will return true. If both conditions are true, then it will return true. If the both conditions are true, it will return as true. If the both conditions are true, then yes, we wanted to find out, in our case, the number should be above 10 and less than 20. The number should be above 10 and less than 20. If the number is above 10 and less than 20, yes, right now we need to display true. Right. Then, yes, now we want to check whether the number is in between 10 and 20. Therefore, in this scenario, we would say now the number should be in between 10 and 20. Now, you can have a variable called, let's say, integer x equals, let's say 15. Then I can check whether I would say validity. I'm going to display something like validity true or false. If the condition is, now there are two conditions to be met. What is the condition? The number should be, x value should be greater than 10 and x value should be greater than 10 and x value should be less than 20. If the x value is greater than 10 and less than 20, then I wanted to display here, well, I want to display the result. Right now, what I'm ending up with here, now here you will see what does it say. Right now, these are very common mistakes everyone will do. Therefore, let's try to figure out what has happened, what went wrong, and then let's try to figure it out how to fix this. What does this say in line number 4? 1, 2, 3, 4 here at this line number. Now, what does it say? Right now, the bracket expected. Right, where are the bracket expected? Right. Now here it says here. Right now, the 10 I have typed as a 1 and 0 as a space. Okay, is it the problem? Yes, because we have typed two numbers. Then no connection here. Right, then that's why here we ending up by getting the error. Right, now you can see if the number is above 10 or less than 20. Now what if we enter 10? What would be the result? Dulangi, what do you think? If the x equals 10, will this return true? Will this return true?
No, no, sir.
No. Why not? Why not? Because we are not checking whether it is equals to 10. We are checking whether it is greater than and less than. We are checking whether x is greater than 10 and less than 20. Therefore, x equals 10 will return false because here we have not used equal sign. If you want to make sure that works for the when x equals 10 and x equals 20 as well, then here we have to put equal sign as well. You have to put the equal sign as well. Right. Now this is how you can try out. Okay, try for the second one and send me the answer via chat, please, quickly. The second question. Quickly send me the answer, please. Now, it doesn't matter now. The number, what we are talking is, it is a positive number, it is fine. If it is a positive number, fine. Or it should be an even number. Even, it doesn't matter, it is a negative, but it should be even number. Now, then it should be greater than 0. X value should be greater than 0. That is to check positive. And if x modulus 2 equals to 0, x modulus 2 equals to 0. Now I'm checking whether it is a even number. X modulus 2 equals to 0. X greater than 0, that is to check the positive number, and x modulus 2 equals 0. Right. Now, here if I try, Now, if it is 10, it says valid because both conditions is true, no? Positive, even. If it is 11, if I have 11, now it will give me false because it is not even number because I have used the AND operator. AND operator, if you are using the AND operator, then both conditions has to be met in order to return true. Therefore, it is failed. The required is not achieved. But if it is minus 10, minus 8, minus 8, then again you get false. X is not a positive number, but it is an even number. Not a positive, but even. Therefore, one condition has been false. Therefore, since if you use the AND operator, if one condition is false, then failed, then the result will be failed. Therefore, you should remember now if is AND operator, if either one is false, the answer is false. If either one is false, the answer is false. Therefore, the AND operator will not work for this. Now let's go and check the O operator. If the both conditions are true, it will return true. If one operand is true, it will return true. Therefore, now either one is true, then it has to return true. Therefore, here we have to use the O operator. Let's check the O operator. Now, when you use the O operator, now x equals minus 8. It's negative, but it is an even number. Therefore, that will return true. Therefore, that will return true. Right. Now, Tehan, here still we have not done the if conditions. No? Therefore, that's why I cannot use the if. Right. Okay, then here this is how we can work with the O operator. Right. Okay, now I wanted to check whether, okay, these conditions, the following conditions, all following conditions. All right, now let's say we have a case where, okay, like this. Number should be what? Should be multiple of 5 plus even number. Number should be multiple 5 plus even number. Oh, above 100. Right now it has to return true, right? The number should be multiple of 5 and even number. If it is a multiple of 5 and even number, otherwise the number has to be above 100. Right. The validity. One of the following. No. All should be validity. Validity will return true. Validity will be true. Right. If one of the following or all should be true. The number should be multiple of 5 and even number. Multiple of 5 and even number, then it will return true. Above 50. Oh, above 100. Right. Now these are the two conditions. Therefore, the condition one, right, we have two conditions given, right? Then use the appropriate operators and then send me the answer via chat, please. How could you achieve? Now the validity will return true if one of the following or all at least one condition should be true. At least one of the following is at least one of the following is true. Now, if at least one of 1 and 2 is true, it has to return true. Okay, write the code and send it to me quickly. Okay, still only one of you have sent me the answer. The others? How could you do it? Okay, I have received another one as well. Okay, let's see how it is correct. Send me your answers, please, quickly. Z equals 20, and then we have validity is at modulus 5 equals 0 and equals 0. Oh, right. In order to increase the readability, we will do something like this. It says 20, 20, let's say 21, 25 is a multiple of 5. Right, but you have missed one part, no? All has not been considered. Right, some parts are missing in your code. Check your code and again send me the correct one, please. Right now, what you have to do now? You know to check. Okay. Now, first you have to check whether the condition number should be multiple of 5. That is achieved. And it has to be an even number. Right now, that has not checked here. Right now, that has not checked here. Then it has to be checked. Number modulus 2 equals 0. It has to be multiple of 5 even number. And also, it has to be above 50. It has to be greater than 50. The second one, it has to be above 100. It has to be above 100. Right. Now let's see. Now it says 25. It's not an even number. Then it is not. If it is 30 and also right now 30 and two conditions has been false because less than 50 no? Now this also false. If it is 75, again false. Why? Not even number. If it is 80, multiple of 5 and even and above 50, then it has to be true. Yes, true. If it is 101, or else if it is 101, now you can see if it is 101, again it says true because why? If the number is above 100, no matter, it should return true. Either condition. If it is the first condition, then there are 3 cases, multiple of 5, even number above 50. Otherwise, it has to be above 100. Then we will be able to like this. Therefore, these check as one condition. O, and because using the brackets, I have done it like that. And O, I'm checking the second condition. Therefore, this is how we check multiple relationships or multiple conditions using these logical operators. Right. Now again, I'm going back to the previous output. Based on this, if you consider only this output, now tell me, without looking at the second operand, when you can say about the result. Okay, when you're using the AND operator, right? When you're using the AND operator, without looking at the second operand, right? When can you say about the result? In which case? There are 4 scenarios. In which scenarios you can tell the result, final result, without checking the second? Tell me when. If the first operand is true or if the first operand is false. Now, basically, only 2 cases you have when you are working in the AND operator. Tell me quickly. Quickly tell me the answer, please. Right? When? Okay, what do you think? When will this turn true? Okay, if the first operand is true, what can you say when you're using the AND operator? Tehan, what do you think? When the first operand is true, what would be the answer?
True.
Oh, not true, Nipute. Here, it could be true or false, neither.
As with the
It
end.
could be true. It could be false, but we can't, without checking the second one, we cannot say anything, no? But if it is false, what can you say about the final answer? If it is
False.
false,
False.
yes. Obviously, if the first operand is false, if the first condition gave you false, then no matter what you have as a second value, it will be false. Is that clear? If the first operand is false, then no matter what you have as the second, operator, then it would be false. Therefore, remember that if the first operand is false, no matter what you have in the second operand, either it could be true or false, it doesn't matter at all. The final result will be false for sure. And when it comes to the true, and sorry, the O operator, in which scenario you can say the answer? If it is true or if it is false.
Is it good?
If it is false, can you say about the final answer? No. Why? If it is false, it may be true or it may be false. Therefore, either one could happen. But if it is true, then you can see here, if it is true, the answer is true. For all the cases when the first operand is true, the result is true. Therefore, when you are using the O operator, if the first operand is true, then no matter what you have as the second operand, the result will always be true. Therefore, we have short circuit AND operator and short circuit O operator. Now we have short circuit AND operator means two AND operators, and short circuit O operator means two O operators. Right now, if you use the two AND operators, right now remember the difference. If you use the normal AND operator, it checks the both sides. If it is the normal AND operator, checks the both sides. But if it is the short circuit AND operator, it checks the first left side, it checks the left side, and if required, then only it will check the second side. For an example here, if the first operand is true, then it will check the second operand as well. If the first operand is false, then it will not check the second operand. It will not check the second operand. Right, then how can we make sure that is not happening? We have to make sure that no. Right, now in order to do that, let's say I'm gonna have I value as 0, right? And I'm gonna check Boolean variable, Boolean flag equals, I'm gonna have let's say I'm gonna have true and plus I greater than 0, or plus I greater than 0, plus I greater than 0, right? Then I'm gonna display the flag variable and also the I variable value. Flag variable, and I'm gonna display the I value and also the flag variable as well. Right, now let's see. Now plus plus I is greater than 0, semicolon missing. Right, now you can see here it shows I value is equals, now previous it was 0, now I value is equals 1. That means what? This side has been checked. Right, now let me change the true into false. Now when it was true, the I value got increased by 1. When it is false, now when it is false, now when it is false, now you can see it has given I value as 1. Therefore, whether it is true or false, it doesn't matter. It gave us, okay, right, true. Okay, now let's say, let's say we have J as well. This is true, and this is false. Right. Now, what is wrong with here? The Boolean variable. Right. Finish. Now you can see I value also got increased by 1. J value also got increased by 1. Therefore, now I'm going to use the short circuit version. I'm going to use the short circuit version. All right. Now you can see when it is true, then it has to check the other side. No, then it will increase the I value by 1. But when it is false, it is not checking the second side. It is not evaluating the second operand. It is not evaluating the second operand. Therefore, it returns false. Therefore, remember now, when you have the short circuit AND operator, it will check the right side or it will check the second operand if it is necessary only. If the first operand is false, then no matter what you have as a second operand, the result will be false. Therefore, it will not check the second operand. It will not check the second operand. Okay, I have a note on it. Remember the difference between the normal O operator and the normal AND operator and the short circuit AND operator. Right, now same way, try out the short circuit O operator also, how it works. Quickly try out and send me the code, how the short circuit O operator works. Right. Then yes, as you send me the answer. Right now, if I use the operator here, now let's see. Here, let's change into operator, normal operator. Now you can see that even if it is true or false, right, and then well done. And then- right now this will return. Right now you can see here, if I have used operator, now I have changed the code. Okay, if I use the operator now, if I equals 0, j equals 0, true, and plus I greater than 0. Plus I greater than 0. Here it has to be plus j, no, that's why it is not used. Right, now you can see in both scenarios, if it is true or false, when you are using the normal operator, it increases the I value or the j value, because why? It checks the second operand as well. Right. Now let's check whether if we have the short circuit operator. Now if it is true, no need to check the second one. Therefore, that's why here this one has not evaluated. That's why it returns 0. Therefore, remember, if it is the short circuit version, right, now remember this very clearly. If it is the short circuit version, if the first operand is true, if it is the short circuit version, if it is a short circuit version, if you are using the AND operator, if the first operand is false, therefore no matter the result is false. Therefore, it won't check the second operand. It won't check. If the first operand is true with the short circuit operator, then no matter the result is true, what you have here. Therefore, this will never check. The second operand will not check if it is not necessary. Right? If it is not necessary, it will not check when you are using the short circuit versions. Right. Now that is how you use the short circuit AND operator and the short circuit operator. Short circuit AND operator and the short circuit operator. Right. Right now for the logical operators, right now the operands must be Boolean. Right now we have done this already. And if the first operand is false, then the outcome is false no matter what the value of the second operand. And when you're using the O operation, if the first operand is true, then no matter the outcome will be true no matter what the value of the second operand. Therefore, no need to evaluate the second operand. Therefore, we can go ahead with the short circuit logical operators. Therefore, the short circuit logical operators will check the second operand when it is necessary. Therefore, the only difference between the normal and the short circuit version is the normal operands will always evaluate each operand, but the short circuit versions will evaluate the second operand only when necessary. Therefore, remember that in your mind. Right. I hope there is no questions up to now. We have discussed this, and then we have the assignment operators. Now we have the assignment operators. Now the assignment operators we have in the assignment operators, we have equal sign, plus equal, multiply equals, likewise. Then how can you use it? Now, for an example, we already use the assignment operator, equal operator, right? Okay. Then if I want to write I is equals I plus 10, then I have to write I equals I plus 10. Now, rather writing I equals I plus 10, I would have done it using I plus C equals I plus C equals 10. I plus C equals 10. Now, this is same as I equals I plus 10. I plus C equals 10. Now, this is same as I equals I plus 10. Right now, if you print the I value, now it will display I equals 0, 0 plus 10 is 10. Because I plus C equals 10. Likewise, you can use assignment operators. assignment operators. We have the we can use with the equals operator, that is the assignment operator, and then we have plus equals, minus equals, multiplication equals, division equals, modulus equals. Likewise, we can use, and then and equals, and there are some bitwise operators, no? Right, and then we can use plus equals, minus equals, multiplication equals, division equals, modulus equals. Likewise, you could use. And also, if you want, let's say now I have variables like I and j and k. And if I want to assign the same value for the all variables, I could say ij equals k equals 50. Right now, if you want to print assign the same value for the all the variables, I could do it like this as well. I equals j equals k equals 50. What happens? First, 50 get assigned to the k, then the value of k variable get assigned to j, the value of variable j get assigned to the variable I. That's how it works. Right, then this is how you can work with the assignment operators. Therefore, quickly try out minus equals, multiply equals, division equals, modulus equals. Quickly try out and tell me how it is working. Right, then we are going into right. Now, when we are working with some numbers, sometimes you may have to convert the types and so on, how we have to convert the values and see. Right, now, for an example, if you can remember, right now when you have two integer numbers and when you divide two numbers, we got the answer as an integer value, if you can remember. And then we discussed that integer divided by an integer is always an integer. An integer multiplied by an integer will always be an integer. Likewise, we discussed under variable data types. Right. Now, for an example, if you want to, right, let's say now we have a byte variable. We have integer I equals 10, right? Integer I equals 10. Right now, obviously, you know that. Okay, if I try to assign for the long variable L equals I, what I'm going to do, the value of variable I, I'm going to assign to the long variable F. Now, what's going to happen? Yes, without any issues, it will get assigned by compatible data types. Therefore, this you call as automatic type conversion or a widening conversion. Right now, we call it as widening conversion or automatic type conversion. Why is it? Because when the destination is uh, greater the source, yes, then automatic type, if it is two types are compatible, if the two types are compatible and the destination type is larger than the source type, then the automatic type conversion or widening conversion is happening. Right. Then integer to long widening conversion happens. Right. Thereafter, right now, now let's say now we know that in a byte variable we can only store from minus 128 to plus 127. Therefore, now if it is a byte variable, right now you know that for sure it can hold 10. It can hold 10, but I have stored integer variable inside integer variable. I have assigned 10. What I'm trying to do is I'm going to assign that to the byte variable. Right now, byte b equals I. Now, obviously, now beforehand, let me right now. Okay. Let's say I have a byte variable I, which is 10. Byte variable I is 10, right? And then I'm printing I value. Now you can see without having any issues, the byte variable value displayed. Now let me change that into integer variable. Okay. Now let's say now this is the byte variable I equals 10, and I'm gonna assign back that into integer variable. Let's say I. Okay, let's say variable for value, integer variable value. I'm gonna assign the byte variable value, and then again for the byte variable, let's say now this is b, integer variable I equals variable d value, and then again after this. Now after this, I'm gonna print the variable I value. I'm gonna print the I value. No worries, you can see this works because automatic type conversion happens byte to integer. Right now, again, what I'm gonna do is I'm gonna reverse the process. But I have copied from byte to integer. Now I'm gonna copy it back to the byte variable. I'm gonna copy back to the byte variable, and I'm gonna print the byte variable value. Now, when I try to do it, now I'm getting an error because obviously it should be possible. Why? I have taken it from a byte variable. I have taken it from a byte variable. I have taken it from the byte variable to an integer. Now I have integer variable contains 10. Now that I have to that integer variable value, I wanted to assign it to a byte variable. But when I try to do it, now I'm getting an error, possible loosey conversion. Because what happened? In this scenario, automatic type conversion happens. The value of the byte variable assigned to the integer variable, and then the type became an integer. Now, integer variable contains 10, which as an integer value. Now here, what I'm trying to do, the value of the integer variable, I'm going to assign to the byte variable. Therefore, now, integer can hold much larger numbers compared to the byte variable. You know byte variable is 1 byte, integer is 4 byte in size. Therefore, integers can hold much larger numbers compared to byte variable. Therefore, trying to store an integer value into a byte variable is a loosey conversion because you will lose the value. Therefore, the compiler will warn you, displaying an error for incompatible types, possible loosey conversion, because the destination is smaller than the destination type is smaller than the source. Destination type is smaller than the source. Therefore, you will get an error. Therefore, in this scenario, you can see automatic type conversion or widening conversion is not happening because the destination is smaller than the source. Therefore, incompatible types. Previously, at this point, compatible types. The destination integer is greater than the byte. Therefore, compatible types mixed. Then it has converted. Automatic type conversion happened. But in this scenario, destination, which is byte, smaller than int. Therefore, we have incompatible types. Therefore, automatic type conversion not happen. Therefore, here you will get an error. But in this scenario, actually, let's say you wanted to make sure, right? If you want to make sure this should happen, if you wanted to make sure this should happen, right then, but it is not happening now because due to the incompatible types. But if you want to forcefully, if you want to do this, there's the method that you call as casting. That means here you need to, inside the brackets, you need to make sure the type of the data type which you want to convert. Now you're going to say the integer convert to a byte and then assign it to a byte variable. Right now, let's see. Now, without getting an error, it will happen because why? Before you do the assignment, first it converted the type of the variable I into a byte. Therefore, now this is what you call as casting. Therefore, in order to do the casting, this is what you call as casting. You need to type the type of the variable. You need to type the type of the variable before the expression. Then it will convert into the given type if it is possible. Now, therefore, here it will convert forcefully. Now, therefore, this you call as the casting. Casting incompatible types. Casting incompatible types. Okay, try out quickly. Right, now let's see. Now we have, let's say, 100. Now, okay, now no need to do the conversion here. No? Let's say I equals 100. Okay, 110. I equals 110. Will we be able to convert 110 into a byte variable value? Right, 110, yes. Byte can hold 110, yes, possible. But I'm going to say 150. Now, 150 cannot hold inside a byte variable value. Now you can see it give us a different value. Therefore, now because the byte cannot hold 150. Even though we converted, the byte cannot hold 150. Now that's why here, right, we have to do the casting. Right now, we have to make sure what you are doing. Right now, previously, if you can remember, if you have x equals 5 and y equals 2, and if you wanted to display like if you want to display like x divided by y, now you can see integer divided by an integer, then it will give you 2 as the answer because integer divided by an integer is an integer. Right now, in order to get this thing right now, if you want to get the float answer, let's say by assuming the result would be a float value if you assign it to a float variable, but that won't happen because why? Now what happens is integer divided by an integer will be an integer. This integer value 2 get assigned to a float variable, therefore automatic type conversion happens, then 2 become 2.0. But you can see it is not 2.5. But if you really want to get it 2.5 as the answer, one value, either x or y, has to convert it into a float. If you want, you can convert x into float by casting. If you do it, then float x divided by integer. Float divided by an integer is a float value. Therefore, 5.0 divided by 2 is 2.5. Then you will get the answer as 2.5. Why? Now you are converting the variable x into the float by casting, and then that divided by an integer value. In this scenario, either x or either y, you have to convert into a float. Right now, check whether the automatic conversions from these. Right now, I have showed you byte to short automatic conversion is happening. Right now, I want you to find out byte to short and byte to int. Byte to int we checked, that is okay, right? That is happening, right? Automatic type conversion. I want you to search for byte to long and let's say byte to float and byte to double. That I want you to search, check. And thereafter I want you to check for the short. Short to byte, you may have to cast, right? Because automatic type conversion is not happening now. And right, and thereafter byte to short, then integer. Integer to byte, integer to short, integer to byte, integer to short, integer to long, integer to float, integer to double, and then long. Long to byte, long to short, long to int. Is it working? And thereafter, I want you to figure out furthermore. Try out float to byte short, int long, and then double to byte short, int long. No. Right now, when you want to do the casting type that you require casting, if it is a whitening conversion happens, like now you can type OK. And then try out for each type and then send me whether you require casting or whether it is automatic type conversion happens or not. Likewise, try out these and send me the answers quickly. Now we have already done this for what? Now previous, okay, I'll show you that how to do it for integer byte. Okay, we have byte variable byte b equals 10. And we're gonna assign it to integer I equals b. Okay, I'm gonna try for the short. Short sc equals b, and I'm gonna print the short variable value. Now you can see here, no worries. It converted. Therefore, now this already tested. Therefore, it is already tested. Automatic type conversion happens. Byte to long, byte to float, byte to double. I want you to try out and tell me which one require the type conversion using casting, or which are incompatible types. Then no, we can say compatible automatic type conversion. Automatic type conversion happens. Automatic type conversion happens. Likewise, I want you to mention here. Right. Okay, then try out for the rest and then complete this and send it to me. Okay, try out this quickly and send it to me, the answers, please. Works. Now, few of you have actually sent me the answers, and then let me delete this and then see how this works. Right, now we wanted to check whether byte to short. Yes, byte to short works, byte to integer works, and byte to long. Just to change it to a long variable type, and then let's run it and see. And yes, that also works. Therefore, automatic type conversion happens there as well. And byte to float. Let's say byte to float. And if it is a float variable type, now you can see 10 became 10.0. Yes, that also happens. Therefore, automatic conversion happens there already. And byte to double, let's change it to double and see. That also happens. Therefore, automatic type conversion happens from byte to short, int, long, float, double. Right, short. And then here we have short data type, short variable to byte. Now, when you try to convert short to byte, now you can see our loosey conversion happens. Therefore, here, if you want to do this, we need to convert into a byte variable type by casting. Right? Therefore, automatic type conversion is not happening. Therefore, casting required. Casting required. And short to integer. Short to integer. Short to integer happens without issues. Short to long, because in same type of values, therefore that will happen automatically. Short to float value. Short to float variable type, therefore that also happens. And short to double. That also happens. Therefore, automatic type conversion happens for short to int, short to float long, short to float, and short to double. Right. And integer to byte. Integer to byte. Like now, let's say here this is an integer variable now, and integer to byte. Right now, obviously it should not happen. Therefore, you may have to convert this into a byte. Casting. Then casting required. Then only this will happen. Therefore, casting is required. Casting to byte. Integer to short. You know the destination is smaller. Therefore, if you want to convert into assign it to a short variable, yes, you need to cast into short. Otherwise, it is not possible. Therefore, casting is required for this as well. Right, integer to long. Yes, the destination is larger than the source. Therefore, automatic type conversion should happen. Therefore, you can see integer to long happens without having any issue. Integer to float. Integer to float. You can see integer to float happens. Integer to double. Now that also happens without having any issues. Therefore, automatic type conversion happens. Right. Integer to long. integer to float and integer to double, that also works. Then long to byte. Now here if it is a long variable and long to byte variable, you know the destination is smaller, therefore obviously it will not. And therefore if you want, you need to convert into a byte variable. Right, okay, before casting I will show you long to short. Long to short will not happen. Long to integer, that also will not happen, right? Because the destination is smaller. Therefore, if you want to convert into an integer, a long variable into an integer, you need to assign it to a cast into an integer type. Then you can do it. If you want to convert into a short variable, because if the value is possible, then only, otherwise you will lose the value, okay? And that is also possible. You need to cast into a short. And if you want to convert into a byte variable, because the Lucy conversion will happen, because you are forcefully casting. Right. Now you can see that is possible. Therefore, here casting is required from long to byte, long to short, long to int, and long to float. All right, long to float. Let's try out. If it is a long variable to a float variable, right? Long to float, right? Long to float. Now you can see long variable b, float variable is long to float. Has happened here. Right now, let's say I have very big number, a long variable to a float. And now you can see integer number is too large. Right now, the long, let's mention it as a long variable. Now you can see you get the integer number. The type of the long variable is integer, then integer number too large. If it is a small number, if it is a small number, if you want to mention it as long, L, right now you can see that get converted to a float. Right now that get converted to a float. Right. Therefore, if it is now remember, if it is not too large, that will happen. Automatic type conversion happens unless it is not too large. Then long variable to double variable. Long variable to a double variable. Long to double. Now you can see it works. And then if it is a very big number, let's say. Now you can see here integer number too large. Right, integer number too large. Right now you can see here we are error. Right, then long to double also happens like now. Right now, see automatic type conversion happens. Right. And then float to byte. Now you have float variable. 1.5. Float to byte. Obviously, you can't do that because decimal value into a byte variable, integer type. Therefore, you cannot. Therefore, you have to do the casting. Obviously, you have to do the casting. Okay, float to long, float to double. Okay, float to double. Now you don't require cast. Float to double. Because anyway, it's a decimal value, float to double. Now you can see without any issues, automatic type conversion happens when it is float to double. And double to byte, no, double short, no, double to long, no. Here, everything requires casting, right? Therefore, keep this in your mind. Automatic type conversion happens only if the automatic type conversion happens only if the destination is larger than the source and if the two types are compatible. If the two types are compatible, then only automatic type conversion happens. If the automatic type conversion is not happening, then you may have to convert that into by casting. You may have to use casting in order to use the casting. Right. Now let's see. Here, when compatible types are mixed in an assignment, the value of the right side is automatically converted into the type of the left side. Right, then when compatible types are mixed in an assignment, the value of the right side is automatically converted to the type of the left. Right, now that is how the automatic type conversion happens. Right, then automatic type conversion happens only if the two types are compatible and the destination is larger than the source. Then you call it as a widening conversion as well. Right, and then if you are casting, that means if you are going to mix incompatible types, then casting should happen. Then the casting should happen. Then when it comes to casting, right, a cast is an instruction to the compiler to convert one type into another. Therefore, it requires an explicit type conversion. Inside the brackets, you need to type the target type. That's how you could do it. Then when you are converting into, when you are using casting, the data loss will happen or the truncation will occur. Therefore, right now, if it is a float value, for an example, right now as a summary, I will show you. Now, if you have a float value, if it is float 1.5, and then if you try to convert into an integer variable, right now, then automatic type conversion is not happening because float to integer. The decimal values has to loss, like let's say 1.59. And if you really want to do this, you need to make sure that is into an integer type. Then what you are making is you are converting the type into an integer, then you will lose. Then 1.59 or 1.99, let's say 1.999. Right now is the value I'm gonna convert into an integer. Now you can see it round down to 1 because it considers only the whole number part, not the decimal value. The decimal value part has lost. Therefore, this is what you call as the type conversion. Therefore, if when you are mixing incompatible types, then you have to use when you are using incompatible types, then you have to use the casting. The target type has to be mentioned inside the brackets. Target type has to be mentioned inside the brackets, and then this is how you do it. Then the value, it will be a lossy conversion or the truncation will happen. Right. Information loss will happen. Right. Okay, then also for the chart. Okay, that was, I think this we have already discussed previously. If we have a integer variable, let's say now integer variable, and if I want to assign it to a char variable, char c equals s. Now I'm gonna put, let's say now this is 65 point something, and I'm gonna print c. Now you can see I'm gonna assign integer value to a char, then this cannot assign, right, a number to a character. Therefore, now I'm gonna cast this, okay, convert into a char. Right, and then if you do it, right now you can say it will take the ASCII value of the variable. Now the variable s contains 65 now. Then ASCII value of 65, representing the character A. Therefore, this would represent character A. The ASCII code is A for this 65. Therefore, you will get A as the answer. Now, this is how when you use incompatible types. That is how you mix the incompatible types. Okay, try out this as well, assigning a value to a character and see. Let's say now integer value contains some value. Okay, 97, and let's say long variable contains 97. Long variable contains 97 L. Right. Otherwise, it is taken as an integer. Right. Then 97 would be simple. Likewise, this will happen. Try out quickly. Right. Right now, this is how you mention a long variable. Like if you want to mention, you can append L at the end in order to say it as a long variable. Now that is how you deal with operators, and then that is how you work with the conversion. Right. Okay, then that's it for the presentation. Right. Okay. Any questions up to now? You can ask now. Okay, write a program for this and send me the answer quickly. Okay, quickly do these two and send me the answers quickly. Okay, these are the questions. I want you to find out how to get this thing done. 1 plus 2, 3, 3, 6, 10, 15. Right. Okay, these three questions I want you to do, and then send me the answers via chat, please. Then we'll wind up. Okay, quickly do it. Write a code for these. Right, how to do the first one? How to do the first one? The others didn't do it, is it? Okay, now the answer came in. Write a program, add 8 to the number 2, 3, 4, 5. Integer result equals 8 plus 2, 3, 4, 5. And then divide it by 3. Then the first we need to add all, you know, the operator precedence. Therefore, we have to add this, and then you have to divide it by 3. Now the modulus of the quotient is taken is 5. Then the entire thing we need to modulus by 5. Modulus by 5. And then the result of this, we can put a bracket, then easily we can get the answer. That multiplied by 5. And then we can display the result. All right, then the answer would be 20. Is that the answer you got? Or was it? Tehan, is that the answer you got? 20?
Yes, sir, but I use float, so I got a.
It doesn't
Yes.
matter, float, but when you use a float variable, will you get decimal values?
Yes, sir.
What is it? 20.0 or any other number?
So it's 25 something. So let me check it.
Right, let's say. In float, oh my bad. Float result. 20.0 I got, like, because now this divided by 3 will be an integer value, obviously, and modulus by 5, the remaining value would be an integer, and then that multiplied by 5 would be an integer. Therefore, it should be a whole number. For sure, the answer is. Right. The second one, anyway, the 20 as the answer I got. But even we could have done this. We could have done this inside the brackets, then no worries. Rather, going into one more step, you would have done it like this. Java test. You get 20 as the answer. Suppose the value of a variable a and b 6 and 8. Integer a equals 6 and b equals 8. Now what it says? Swap. How can we swap? Natika, how to swap? Natika, how to swap? How can we swap? How to swap a value? How to swap a value? Then we have to introduce another temporary hold variable. Let's say integer temporary t equals a. And thereafter, what I can do? Now, a value we have copied to variable t. Now, we can assign value of a, value of variable b to the variable a, and then value of variable b, we can replace with value of variable t. And now, beforehand this, we could display a and b values. A plus b. Now we can display a and b values. Right now you can see initially 6 and 8, then 8 and 6. That is how you swap. Right, we have done these two tasks now. Write a program to calculate the sum of the first and the second last digit of first and the last digit. 1 and 5. Very easy. Now 6. As a homework, try to when you have given a 5-digit number, try to get the sum of all the numbers. Sum of all the numbers. When you have 5-digit number, try to get the sum of all the numbers. Right, then this is very easy. How can you get the first and the last digit? Very easy. What is it? Now I want someone to help me on this. Integer number is equals 1, 2, 3, 4, 5. How to get the first number of it? Integer first. First number. How can I get it? The first number. It is a 5-digit number. Then if you divide n by 10,000, what will happen? If you divide n by 10,000, it will return 1. It will, if you n divided by 10,000, integer division, then 1. Right. And the last number, integer last number. How can I get the last number? Can someone comment on that, please? N. How can I get the last number? That 5 I want to get. How to get it? Please talk. Nirang, how to get the last number? That 5 I want to get it. Using? Okay, I will give you hint. Modulus operator you could use. What is it? Vidyas, how to get this thing? The last number. No idea. Oh. Vidyas, yes. I can't hear you, Putin. Using which operator? Okay, I said modulus. Modulus what? N modulus? Okay, there might be a technical issue. Tehan, N modulus what?
So 1, 2, 3, 4, 0.
1, 2, 3, 4, 0. No, everything. Okay, if you divide it by 10, tell me what will happen. 1, 2, 3, 4, 5. If you divide it by 10, what will happen? Then 1, 2, 3, 4 times you have. And then 1, 2, 3, 4, 0. And the remaining value is 5. We want to get this number, right? N modulus 10 does this, isn't it?
Yes, sir.
Right, see how easy it is. And then we could display the first and the last is 6. You could calculate first plus last. It give you 6. Right, now as a homework, when you have given a 6-digit number, right, when you have given a 6-digit number, calculate the sum of the digits, sum of the digits, sum of the digits, sum of the digits of a 5-digit number. Right, 1 plus, 2 plus, 3 plus, 4 plus. Likewise, I want to get it. Right, get the I'll write the code to get the sum of the 5 digits. If it is a 5-digit number, send me the answer to the WhatsApp. You can post to the WhatsApp group. Okay, how to get this thing done. Right. Any questions you can ask now? Other than that, we can wind up for today. Any questions you can ask now? Other than that, we can wind up today.